Okay, so this is the final lesson in the redox unit. It's about voltaic and electrolytic cells, also called electrochemical cells. Electrochemical cells are chemistry that creates electricity or uses electricity. There's two different types. There's the electrolytic cell and there's the voltaic cell. We're going to look at those two. So, start off, talk about this. There's a couple terms you need to know. The first term is called spontaneous. A spontaneous reaction means a reaction that naturally occurs. This is not to be confused with instantaneous. It doesn't instantly happen. It just means spontaneous, just means it will happen. The next term is electrode. Electrode, that's your generic term. Either anode or cathode. First one is cathode. And then cathode is the electrode where reduction occurs. The way you think of that is red cat. Anode, the electrode where oxidation occurs. The way to think of that is anox. So oxidation at the anode, reduction at the cathode. You can also think about this in table J. Table J, the elements that are at the top of table J, they will be the anode because they are oxidized. The ones that are lower down are the cathode. They will be reduced. A comes before C, just like O comes before R. All right, oxidation is before reduction. O is on top, R is on the bottom. Anode's on the top, cathode's on the bottom, same thing. Next term is a voltmeter. And a voltmeter obviously is just measures voltage, which is current or electron flow. And then the last one is salt bridge. A salt bridge is part of a electrochemical cell. The point of that is it allows ions to flow back and forth. In the batteries that you have in your phones or your flashlights or whatever, the salt bridge is represented is made by a paste infused paper. So this is a voltaic cell. A voltaic cell is a spontaneous electrochemical cell. It does generate electricity automatically. This is your typical batteries. Anytime of a battery, you hook up a battery, all right, this is a voltaic cell. It creates voltage. Think of it that way. There's a couple different parts to this. There's the one side over here. This is the anode side. Then you have the cathode side. The anode side is the element that is higher on the periodic table, on table J, than the other one. So if you look here at anode, we have two elements, two electrodes. One electrode is the zinc electrode. The other electrode is the silver electrode. Because zinc is higher on table J, zinc will be the anode, silver will be the cathode. Zinc will be oxidized, silver will be reduced. Zinc will lose electrons, silver will gain electrons. Remember, oil rig or Leo goes Gur. Loss of electrons in oxidation, gain of electrons in reduction. So what's happening on this cell here? There's a couple different parts. This is the cell, okay? This thing here through the center is the salt bridge. This salt bridge allows ions to flow, so you don't have a backup of ions, too many ions. Well, if you think about this, and then this is the wire, external circuit. A wire goes to a voltmeter, just tells you the electricity is flowing. Sometimes there'll be a switch in here as well. When the wire connects this electrode here to this electrode here, connects the anode to the cathode. That's what the wire is for. So in this cell here, the left cell, the zinc cell, what we have happening is we have zinc, all right, being oxidized. Zinc, as it's oxidized, loses electrons. Those electrons flow through the wire. They go through the wire. They go over to the cathode. Over at this side, we have silver being reduced. Silver is being reduced from the silver ions that are in solution, taking those, combining them with an electron, and making silver atoms. Now, if you were to think about this, on this side over here, on the zinc side, all right, over here, what's going to happen is you're going to have a buildup of these zinc ions. There's going to be a whole lot of zinc ions over here because as every zinc metal becomes a zinc ion and releases an electron, it flows into solution. So you'd have all these extra zinc ions. Over on this side here, you'd have all the silver ions being gobbled up because as an electron comes in, they gobble up an electron coming into silver. The salt bridge here, the salt bridge allows electrons to flow from this side, positive ions to flow from this side over to this side, and build up of negative ions to go in the opposite direction. So that's what a salt bridge does. It allows your ions to flow. It keeps your battery a full, complete circuit. Okay? You may have seen this kind of an idea before, using lemons, all right, to make a battery. Well, what you have going on here, see this little light bulb right there, that little light bulb, all right? That little light bulb is lit up because we have a lemon. They're all hooked up in series. And if you notice, we have a zinc nail and a penny. Zinc nail, penny. Zinc nail, penny. Zinc nail, penny. What's happening is this light bulb, one side of the light bulb is connected to the zinc nail. Then there's a penny in here. Penny shoved into the lemon as well. That penny is connected to the next zinc nail. Then you go the penny to the next zinc nail. This penny to this zinc nail. This penny back to the other side electrode on the battery, or they should be on the light bulb, and you have a complete circuit. And there you go. This is a virtual voltaic cell. You want to keep table J in mind here. So we're looking at virtual voltaic cell. I have it open here. Okay. Here's our virtual voltaic cell. Okay, I'll move right there and put it right in the middle. So it says, please select metal to be connected to the red wire. So over here, so we have to go up and select a metal. So they give us three choices: silver, copper, zinc, or the hydrogen electrode. I'm just going to ignore the hydrogen electrode. We're going to do silver, copper, zinc. So if you look on table J, you'll see that table J, the highest one is zinc. So we'll put zinc there, okay? And then, so we did that. Don't need to show you. Now select the metal to be connected to the black wire. So we go over here, and we'll do the same thing. Now we can't do the same metal. We can't do zinc also. We have to do a different metal. So we'll choose copper. All right? All right? And I'll keep that on, what the heck. So we'll close that. And now we got like solutions. Well, this is a copper ion, so we're going to have a copper solution here. Copper solution's right there. Close that up. Over here we have a zinc ion. We're going to zinc solution. Zinc solution. All right. And now what we want to do is we want to open this switch. Right now the switch is closed. So as soon as we turn this on, click that on, you can see electrons leaving the zinc here, going through the wire, going across there, making that light, going back over here. And what's happening here on this side is these electrons are combining with zinc ions to form zinc atoms. Over here you can see the zinc ions building up. See, as the electrons leave, another pair of zinc, another zinc ion goes off into solution, zinc 2+. All right, so we're going to turn it off. Turn off these directions. Turn it off, and we can do this again. So let's choose a different metal. So we'll do over here, we'll do one that's, last time we did zinc, this time we'll do silver. We'll do a silver solution. Over here we'll do copper and a copper solution. All right, now what's going to happen this time? Look at table J and see if you can figure out which one's going to be the anode, which one's going to be the cathode. The higher one will be the anode. Okay, yes, copper is going to be the anode. So this time when we turn on, electrons leave the anode this way and go across over to here. And so you can see that silver ions over here, they're all being gobbled up. The silver ions, they gobble up, each one of these electrons grabs up that, and it's grabs an ion, it gobbles it up. Over here, we have a buildup of all these extra ions, and this salt bridge is allowing this to flow. If we could zoom in here, sometimes they allow you to zoom in, but this one doesn't allow it for whatever reason. But that's essentially what's happening here. Okay? Let's go back to our lesson. Because zinc was higher than silver, zinc was being oxidized, silver is being reduced. The other type of electrochemical cell is called an electrolytic cell. An electrolytic cell, these are non-spontaneous. They require energy. They're non-spontaneous. They require a source of electricity. This is your phone battery when you're recharging it. When it's discharging, it's a voltaic cell. When it recharges, it's a electrolytic cell. So a couple different uses for electrolytic cell here. They also show silver plating. So here we have a silver bath, a bath of silver ions, a bar of silver, and a metal fork, an iron fork. And so what they're saying is, okay, you're going to hook up a battery here, you're going to pump electrons onto the fork. Well, as those electrons gather on the fork, silver ions are going to be attracted to those electrons, and they're going to combine and form a coating on top of that fork. That's called silver plated. Silver plating is a process through electrochemical reactions. Over here, we also have the same idea. Here we have molten sodium chloride, and they're showing you two different, this is molten, so it's really, really hot. They use an anode and a cathode here. At this cathode, we're going to have sodium ions being reduced. And over here at this anode, we're going to have chloride ions being oxidized. And that, too, is an electrochemical cell. The last example is the, it's called the taking water, well, it's called the dissolution of water, or the separation of water from water into hydrogen ions and oxide ions. When you do that, what we have is we have the water naturally dissociates, all right? And so we'll run electricity through it. Over here, on the cathode, we have the hydrogen ions. They are grabbing electrons, having electrons added to them, and forming hydrogen gas. And so they form hydrogen gas, and the hydrogen gas is going to bubble up here, and it's going to form here. Whereas at the other electrode, you're going to have oxide ions having electrons removed from them, the O2 minus having electrons removed, and they will form O2 gas, oxygen gas, and create 2 electrons to be used. Those 2 electrons are going to be used over here. That's how it completes the circuit. This is what happens in a fuel cell or a fuel cell car, those kind of things, up in the space shuttle or in the International Space Station. They're constantly taking the water. They're taking the water and separating it from the H2O, changing it from H2O into oxygen and hydrogen gas. And then when they need electricity, they just run it in reverse and produce electricity. So overall, here's the overall salient points. Voltaic cells. They are the spontaneous ones. Electrolytic cells, they are the non-spontaneous ones. Okay? The difference between them is listed here. Anode is negative in a voltaic cell, but it's positive in an electrolytic cell because you're pushing the electrons in the opposite direction. The next step will be to use this knowledge and to complete these questions here. So topic 9, page 165 to 168, work on those questions. Those questions will be answered in the next video.